If the puck's final speed is 43 meters per second, what is the initial speed? All right, so let's start, as always, with our givens. What's one thing that's given to us here in this problem?
We got the distance.
Yeah, you got the distance, right? That's the
So it's 55 meters.
55 meters, right? That's how far the puck is sliding. Good, that's our delta x. Thanks, Jose. What's another given that we have?
You have the final velocity.
Yeah, we have the final velocity. That's right, Danya. And what's the final velocity?
43. Yeah.
43.
I don't know what it, I don't know what.
M over S. Can somebody help her? What's M over S?
Meter per second.
Yeah, meters per second, right? The M is meters there. Right. If you think. Go ahead, Angel.
Delta T.
We have delta T, right? Exactly. What's that going to be?
1.5 seconds.
Perfect. And just remember, a lot of people always call meters per second miles per second. But if you think about it, going a mile in a second is a really insanely fast speed, right? So that can maybe help you remember that it's meters per second, not miles per second. You can go a meter in a second pretty easily, but it would be pretty crazy to be going a mile every second. Okay, so we have our three givens, right? What's the unknown? What are they looking for here? Initial velocity, right? So our Vxi, that's what we need to find. Okay, so so in step 3 now is to pick the right equation to use. Which of our kinematics equations has these 4 symbols in it?
The first one.
The first one, right? Yeah, the first one's got Vxi, Vxf, delta t, and delta x. Okay, so we'll choose the first equation. Delta x equals 1/2 initial plus final times our time. All right. So we've got step 3 done. We've picked our equation. Now we need to rearrange it, right? And this rearranging is a little bit tricky. We've got to get Vxi by itself, and it's inside parentheses here, right? So the first thing to do whenever the unknown is inside the parentheses is we want to get the parentheses by itself. All right, so we need to get rid of the 1/2 and the delta t. How can I get rid of the 1/2 and the delta t from the right side of the equation?
Dividing it?
Yeah, what should I divide?
Delta t and 1/2?
Yeah, exactly. If I divide by delta t, it cancels out here. I can divide by 1/2 and it'll cancel out there. And I've got to do it to the other side as well, right? So divide by delta t. And I would divide by 1/2, but the exact same thing as dividing by 1/2, right, is multiplying by 2. And it looks nicer and it's easier not to screw up in the calculator, so I'm going to multiply by 2 instead. So what I have here is 2 times delta x divided by delta t equals what I had in parentheses before, the Vxi plus Vxf. Right? And I can get rid of the parentheses now since it's the only thing on that side of the equation. So I've got one step left now if I want the initial velocity by itself.
I have to subtract the final velocity.
Yeah, that's perfect, Isabella. We got to subtract the final velocity, right? It's being added on, and we undo addition with subtraction. So Vxf minus Vxf cancels out on this side. I'll have to do it on that side as well. So if I rewrite it, I find my initial velocity is equal to 2 times the displacement divided by the time, and then minus final velocity. All right, I think that's right. And now we can, so that's step 4, right? We rearranged our equation, our unknown is all by itself. And now for just plugging in. Right, so we have 2 times 55 meters divided by 1.5 seconds, right? That's our delta time. And then we subtract the final velocity, so minus 43 meters per second. Okay, so 2 times 55 divided by 1.5. That'll give us 73.333, and then I still need to subtract 43 meters per second. So 30.3. And if you get something different, let me know, but I think that's the right answer. So 30.3, and I've got
Meters per second.
meters per, what did I do here? Oh, yeah, that's, sorry, how should I label that? What symbol should I use for what we're looking for here? I wrote delta T.
VXI.
Yeah, that's our VXI, our initial velocity.
Initial velocity.
Yeah. And we've got meters over second here, right? That's meters per second, and this side as well, meters per second, and that's a velocity. So we're pretty sure that that we did the math right, we did the algebra right. And if we're talking about something that had been, or that was going at, that's going at 43 meters per second at the end, it's pretty reasonable that it started at 30 meters per second. That seems like we did all right here. Any questions about the problem of the day for today? Okay. I didn't post a new